Thank you all for your support. And now I can finally do an intro. So I'm Alina. I'm a developer advocate for GraalVM at Oracle Labs. And Oracle Labs is this R&D unit at Oracle where we're doing a lot of research. GraalVM is probably one of our biggest projects, but outside of it, we're doing a lot of interesting things in domains like compilers, programming languages, machine learning, things like that. And also, I love open source and communities a lot. If you're a fellow community organizer, please come to talk to me. I would enjoy talking with you. And also, I'm Ukrainian. The city that you hopefully see, yeah, you can see it on my slides. That is my beautiful hometown, Lviv, in Ukraine, where I still live. And I hope that one day it will be safe and possible for all of you to come there and like the city as much as I like it. Thanks. So that is it for the intro, and now let's talk about some Java and GraalVM and how you can build really cool applications using GraalVM Native Image. So a very quick recap for those of you who may be less familiar with GraalVM. GraalVM is this high-performance virtual machine, and there is a number of things that you can do with it if you are a Java developer. So the first thing, you can use GraalVM as your normal JDK. So if you're using, let's say, OpenJDK or any other distribution, you can just as well use GraalVM as your JDK. In this mode, you can use all your favorite tools and libraries. All of that is accessible and working for you. And the only thing that has changed comparing to your standard kind of OpenJDK setup is that we are replacing the top-tier optimizing compiler with our brand new highly optimizing GraalVM compiler. And many applications will see additional performance just by switching to GraalVM as a JDK because this compiler is so good at optimizing Java code. So that is one big part of our project. The next big part is what we actually will be talking about today is the native image. So native image is this ahead-of-time compilation technology for Java that allows you to produce native platform-specific executables of your Java application that no longer require a JVM to run. And last but not least, GraalVM is also a polyglot VM. So in addition to executing Java and traditional JVM languages such as Scala, Kotlin, Clojure, you name it, GraalVM can also execute all those languages such as JavaScript, Python, Ruby, and so on. And not only it can execute each single of those languages, but it can also execute polyglot applications. So applications written in a number of those languages, so you can easily use different tools, different libraries, code from different languages in your one polyglot application. So that's an overview, and one of the things that also I particularly like about GraalVM is that it's also an open source project. So our development is happening on GitHub. That is the place where we work on issues, pull requests, projects. If you're a Java developer, I recommend you check it out. It's a really interesting project to take a look at if you are a Java developer specifically. And now let's talk a bit more about native image specifically. So native image takes your Java application and produces a platform-specific native executable of it. And the reason, the motivation why you could be doing such thing is to get this fast startup and low memory footprint of such application because it no longer requires a JVM to run. So you can deploy it on a machine that does not have a JVM on it, and it will still be fully functional and fully working, and it will start really fast. And that is the reason why also so many Java microservices frameworks, such as the ones you see here on the slides, are using native image. That is to get those startup and memory usage benefits from native image. And to give you an idea of what is happening behind the scenes when you run a native image build, the idea is the following. So when you run your application at the image build time, we are trying to perform as many heavy operations, as many computation-extensive operations as possible. So you can do it once at the image build time, and then you can start your application really fast as many times as you have to start it, because all of that has been already done at the image build time. So that's the idea. Talking a bit more about the implementation and how it's actually happening. So when you're running a native image build, what is happening is native image will take a look at your application, starting from its main entry point, and it will try to find all the reachable code and then initialize it. And it will repeat this process in steps to find all the reachable code, so all the code that is actually necessary for your application to perform, and then only that code will be included in the final produced native binary. So this way, native image is also eliminating the code that you're not actually using in your application, making it as slim as possible. So it will compile that code, but another interesting thing that Native Image will do, it will also perform snapshotting of your heap so that you can start with a pre-populated version of your heap so much faster. So sometimes people refer to Native Image as ahead of time compilation, and that is true. But another important part of this process is this snapshotting, where we take a snapshot of your application at the image build time, so you can start with this ready-to-go state when you are actually running your application. And comparing to running on a JVM, running on native image is so much faster because, as we said, we are moving all that expensive operations at the image build time. So unlike on a JVM, you no longer have to load classes, start interpreting, start compiling, and then at the final point, you will run with your warmed up, really greatly performing application. Unlike that, we already done that all at the native image build time. So when you actually run your application, it can start so much faster. And the same actually applies to the memory usage. So comparing to the running on a JVM, you can see how much less memory is needed for a native executable because you don't need to keep around memory for the JVM executable itself, compile a data structure, or things like that. You can just start with a pre-populated heap and your application is good to go. Now, let's talk about some practical things that you can do with native image. So if you want to build maybe your first native image application, one recommendation that I have to you, please give our native build tools a try. So those are our official Maven and Gradle plugins coming from our team. And those will simplify for you building, testing, and deploying native image applications. Talking about testing, one more thing that they are enabling is also JUnit testing for native applications. So if you want to build your first application, it will be my recommendation that you give those a try. Now let's see if I can show this to you in practice without breaking this hardly achieved setup. Okay, it should be good. So here I have a few demos, and the first one we will look at is this one. So this is my Java application with tests, and if we look at it, okay, looking good so far. So here's my main application class, and one more thing that my application has is this calculator functionality that is performing, well, some calculations. And to make sure that my application is working correctly, also in my test directory, I have some tests that are verifying that behavior. So to verify that, and let's also look at my POM XML. Okay, this is looking good, and I have my Maven plugin coming from GraalVM build tools. So to test this application, what I would do is the following: Maven, okay, I missed the dash, vnative test. So now it will build my application in the native image mode, and it will also build and execute my test in the native image mode. And we will take a look at that in a second. One thing I have to say here, though, is that this is not mandatory to perform such testing in the native image mode on every single change you're making to your application, especially if you're making changes to, let's say, your business logic. So normally you would test on a JVM, and then as more or less final step in your development process, if you want specifically to verify things working in the native image mode, you would do this, but this is not mandatory to do this on every single minor change that you're doing to your application. So my application is built now, including tests, and as a part of this building process, I also have my tests run and saying that they are successful, but let's verify that once again. So I see that my tests are in this target native test directory. So let's try executing them and see if we can get the same results. Okay, so they're in target, native tests. Okay, so I'm running and I see that my tests that I have over here are working. So each of them is successful, and this was run in the native image test mode. So this is one recommendation that we have for testing. Please use our official build tools from the GraalVM team. And another thing that I want to share with you is one more way to test applications. Let's see if this works. Yes. So another thing I want to mention is that if you're using one of those frameworks that we've seen before, right, so the Java microservice frameworks that are integrated with native image, all of them are offering you some testing functionality out of the box. So if you are building an app using one of those frameworks, you can just leverage the testing support that is coming from your framework. And as an example here, I just want to mention one thing specifically because I like this Micronaut test resources project a lot. So this is a project within the Micronaut ecosystem that allows you easily test against external dependencies, such as, for example, your database, especially in a case if you don't have that, let's say, database set up on your development machine or in your development environment. So that's an easy way to do it without basically manual configuration needed from your side. But this is something you would do for development purposes. And then, of course, in production, you would have to have such a database or whatever dependencies set up properly. But this is a great way to test against such external dependencies. And one of the ways how this is working is through leveraging test containers. And we all know and love test containers, right, as a way to test our applications. And one cool thing I want to show there is actually using test containers and Micronaut test resources. So this is one thing. And let me find this project. Where is it? Okay, I think we closed it, but we can open it again. Okay, it's here. So here I have a Micronaut application that is basically a book app that is trying to put some books into a MySQL database and then get that list of books. And to ensure that behavior, we have some tests over here where we are setting and getting those books, and another test which is doing a greeting. So this is it, and I ran it before the talk, and this was the very first time I tried running it using test containers, so I will just show you the output to save us all some time and trouble, but this is basically the way to do it. So this app here I'm executing with my Gradle native test task, and as it is building, it is also spanning a MySQL container for me coming from Test Containers Cloud. And it is doing all this work. It is building a native version of my tests. And then in the end, it's telling me that we have tested against MySQL successfully and that our greeter test is also working correctly. So this was built on my machine, but this is using this lightweight testing container coming from test containers, which is super cool. So I really like this project from the Micronaut team. You should give it a try as well. So that's another way to summarize this. To test native images, please use our build tools plugins or use whatever is the testing support coming from your framework of choice. Now, GraalVM and reflection. Amazing topic. How many of you have heard that GraalVM doesn't support reflection? More or less half of the people, which makes me a bit sad. So GraalVM does work with reflection, but there are some things to consider. So by default, when you are running your native image build without any configuration, what it will do, it will try to resolve those reflections call for you. And here probably I have to take a step back and tell you that that native image build process that we talked about before is happening under a closed world assumption. So since we are compiling our application ahead of time, we don't know yet what will be happening at the image runtime. So more dynamic features of Java, such as, for example, reflection, need this configuration to work in the native image mode, because ahead of time, there is no way of knowing what will be happening at runtime. So what are the ways to tackle this, and what are the ways to build an app that is using reflection? One thing you can do, one thing native image will do, it will try to detect those reflection calls for you. But in case such an analysis is not producing all the necessary configuration, it might be required from your side, and there are a couple of ways to do it. One is to produce this configuration manually, which could be a bit more challenging for bigger projects. Now, another way to do so would be to use our tracing agent that is coming from our native image, and this way you will observe your application behavior on a JVM. Tracing agent will collect this configuration, produce configuration files for you, and then these configuration files can be used by native image when building an app to produce an app with this configuration in mind. And one thing I do have to say here, though, that native image agent helps significantly, but please, if you're using it, double check that this configuration is complete to make sure that it's indeed included everything needed. So it's helping, but please double check that this configuration is complete. And last but not least, if you're using one of those frameworks that I mentioned that are integrated with native image, all of them will also help you figure out reflection for you. So with that being said, let me show you how to work with it. Okay, so here we have our app that is doing reflection, and it's doing so in a quite an interesting way. So here's my application, and it's trying to access this message field from the message class that is over here, but it is doing so in a, let's say, non-trivial way. And the reason why we are doing this in such a complicated way is to try and confuse native image, because if this was written in a simpler way, native image could figure this out automatically. So we are on purpose doing this in such a non-obvious way to try and avoid native image figuring this out, just so I can show you in a demo how you would configure this with an agent. So let's do this. Yes, Java application with reflection. We're in the right folder. And let's go to my POM XML, and let's find our agent configuration. Okay, why I didn't see it? No, this is not the one. This is the one. Okay, so this is my POM XML from the Java application with reflection file. And here I have GraalVM native image agent disabled. So let's build this app and let's see what happens. And let's do this in the following way. And I think I'll also skip tests so it doesn't complain to me at the image build time. And let's package this. Okay, so now the application is building, and it's not a big one, so it should not take that long. It should be up any second now. Okay, and it's produced, and it's called example app, so let's try running it. Okay, so it runs, and you can see that it has been built, and it runs, but it throws us this message saying reflection is not working, and that is happening in the exception case here, when we cannot access that message because we are not aware of this reflection configuration. So let's fix this, and let's do so in the following way. I'm just keep getting lost in my folders. So let's go back to the agent. Let's enable it. Okay, this is saved. And let's now do the following. So let's do the agent run on the JVM to figure out this configuration. And for that, let's first take a look at our native agent output. So here we have our reflect config file, but it's empty yet, so we don't have any configuration at this moment. So let's do the agent run. And bam, magically, we now have our configuration. So let's try building our application again. And let me just once again verify that our agent is on. Enabled true. OK, and let's build our application again. And now if you pay attention, so here it also specifies now in the whole native image build command, it's also specifying where those config files are from, because now they are available and now the agent is actually working. So it's building our application. It's again compiled, and let's try running the application. OK, so now it says hello native, and that hello native message is coming from our message field of the message class that is now available. So this is the way you would configure using a reflection in such an application. So let's go back here. And yes, so what about reflection in third-party libraries? So maybe you can configure this for your own app, but it could be the case that those external dependencies that you are running are also using reflection, and then what is the way for you to figure it out? There is a way, actually, since recently. So our team has built out this GraalVM reachability metadata repository on GitHub, where people from the community, people from those library teams, people from framework teams can contribute, share, and then reuse metadata needed for different libraries and tools to be accessible for native image builds. So let me show you what it looks like. Okay, our browser is not there yet. Okay, now we are on. So this is this reachability metadata repository where you can see how to start contributing and how to start using that repository. And let me actually show it to you how it's working in practice. So this is the one. Okay, so what I have here is an application that is trying to use H2 to put and then read some customers from a database. And let's look at my POM.xml, and there I have this one specific config that is enabling access to the metadata repository. But let's say I don't have this on, so maybe I don't know about this. So let's save this, and let's try building this application. Okay, this one might take a while, but in the moment, we can also appreciate our nice native image build output that is telling you very specifically what is going on. So for example, here we can see that I'm using GraalVM 22.2, which is the latest production release, and it's showing how much time is spent in each particular step, and it even contains links so you can read more about each step on the native image build process. But it's compiling, so the app should be up in a few seconds. Okay, compilation is done. Now we are creating an image, and it should be up now. Okay, it's up, and it's in a target directory called H2 demo. So let's try running this app. And it fails. And who doesn't love it when live demos fail, right? So the reason it fails, it says it cannot figure out how to work with H2, basically. So luckily, this one is easy to fix. All I have to do is just go back to my POM.xml and enable back this access to metadata repository. So when I save this, and I will rebuild my application again, it will start building, and as it is building, we can actually see how it is accessing this metadata repository, and I think we can even see a specific commit with that metadata for H2. So what is happening behind the screens here is that our native image build will go here to this repo, more specifically to the metadata folder, and here it will look for the metadata necessary for our build, in our case for H2, but you can also see here things like configuration for Hibernate, PostgreSQL, and other things. And I also want to mention that this is a community project, so this repository is built up together with our partners from the Spring Boot, Quarkus, Micronaut teams. So huge thanks for them for helping us in this effort. So it should be built now. Okay, and let's give it another try. Okay, so now it actually runs, as you can see, and it's able to put those customers and then read them. And the only thing that changed is I enabled this access to the repository. Also, you can notice how I'm not saying here any configuration manually, so I'm not providing any parameters such as I want to access H2, I want to pull it for this version, and things like that. So everything I'm doing is just enabling back this access to the metadata repository, and this is fixing this issue with figuring out the reflection for using it. So that is that, and I think I'm running out of time, so let me speed up a bit. So this was using metadata. Now let's talk really quick about performance. So talking about performance of native image, you may have seen charts similar to this that tell you how native image is great for fast startup and low memory footprint. But then again, when it comes to throughput, really probably the best shot you have is running on a JVM, because JVM having that dynamic code execution and having that profile information is really good for optimizing for peak throughput. So what we can do about this, in addition to having that fast startup or like instant performance of native image, you can also make sure that it optimizes really good for peak throughput. And having those particular optimizations in place, we will talk about in a second, you can achieve performance that is comparable to running on a JVM, in addition to, as previously, having fast startup. So to do so would be the following way. You can use profile guided optimizations to build an instrumented binary of your application, collect profile information, and then use those profiles to build a binary with profiles in mind that will have really great peak performance. And let me see if I can super quickly show this. Maybe I will not build the app again, but I will just show the difference having PGO in place can make. So here I have this application that is using streams. And what the application is doing is generating this set of random persons here, and then it's doing some filtering operations, trying to reduce the data that we have to one number, return it as a double, and it will repeat this benchmark in iterations to give workload to our application. So I think I have it even compiled, so we can skip the compilation steps, and let me just go to this folder. Okay, so here I have two versions of this application, and the application is also asking us to provide an input, two numbers. One is the number of iterations and also the length of data array. So I will not recompile it, but I will show you quickly the difference that having profiles can make. So let's run this application. Let's give it some input and see how it performs. Okay, so this was having PGOs in place. The total time of execution is 400 milliseconds for all of the iterations. Should have run the one without the PGO first, but let's run it now and see how it will perform comparing to the previous one. Streams. Okay, it's taking some time longer, so having those profiles really helps to optimize for the best peak performance of your application. And I see that we are really out of time, so let me go through the rest faster. And talking about performance, some more things you can do in native image is that you can use different GC options. One of the options that you probably want to use for optimizing for peak performance is G1, that is available in GraalVM Enterprise Edition. And for monitoring of native image applications, one thing we have is JFR support, which is still work in progress, but there are quite a few events that you can observe already, especially around system-level events or custom events that you create yourself. And on the roadmap, we also have a JMX support, which is also a community contribution. So this is coming in one of the next releases of GraalVM. And one more thing you can do, so in case you are specifically interested in packaging size of your produced binary, you can compress it using something like UPX. And this way you can, for example, go down from having an image size of 66 megabytes to just 17, as we see an example here. I do want to mention, though, that depending on the compression type that you are making, this can have a runtime impact. So use this carefully, but this can really help if you want to optimize your packaging size of your binary. And one more thing you can do, you can also build static and mostly static native image applications, and those could be used, for example, in distro-less containers. And tomorrow we have a whole hands-on lab to talk about this topic, among other things. And what's new, so we are working quite a bit on developer experience. For example, we are making sure that development builds, so native image builds can be quite fast, so you can get feedback in your development cycle faster. And also, IntelliJ IDEA in their early preview builds, they enabled debugging of native image applications. So this is still experimental, but looks super exciting, waiting for more updates from them. And if you want to learn more what is coming in GraalVM, we have this community roadmap on GitHub, where you can learn what is coming in our upcoming resources. And what's next for native image? So we will keep working to make sure that you can easily use libraries in your native image applications, keep working on peak performance improvements, keep adding more GC options and improving GC performance, and keep working with Java framework teams to make sure that you can leverage all the native image features in your applications from those frameworks. So to get started, we have releases every 3 months, and we also have developer builds if you want to try what is latest and greatest in GraalVM. And to get started, you can just go to our website, graalvm.org, or if you are using SDK Man, it's super easy to install GraalVM on your machine as well. So a quick recap: more performance in JIT mode, fast startup with native image or polyglot applications. That is everything you can do with GraalVM. With that, that's all. Thank you. This is my name. This is my Twitter handle. In case you want to ask me something, I will also be around all the days of the conference. So if you have any questions, I would be happy to answer those. Thank you again for coming to this session.